Hello, and welcome to another creative coding video. This time we're going to look again at the new way of mixing color that we started looking at in the last video. In the last video we looked at it quite exhaustively and we explored a lot of different aspects of it, and that video was quite long, I have to admit. So today we're going to have a much smaller example to look at, and we're just going to focus on some of the basics of this new way of mixing color. So let's remind ourselves what we were doing. Now, we've been using color quite a lot in all the videos up to this point. We started by using colors by their name, by using the word red, for example, green, blue, pink, and so on. Then we moved on to mixing our own colours by mixing red, green and blue light, and different amounts of red, green and blue light gave us different colours, and that's quite common in computing. The reason is lots of the displays that we look at, like a monitor or your smartphone or a tablet, will have tiny little lights, little pixels, and they are coloured by using even tinier red, green and blue lights, and varying the amount of red, green and blue gives us different colours. But it's not a very intuitive way of thinking about colour. If we said, what are the red, green and blue values needed to make a yellow or an orange, that's not easy at all to work out. And you shouldn't have to. So we looked at another colour model which isn't called RGB, it's called HSB, hue, saturation, brightness, and it's a little bit more intuitive. It starts with this idea of a colour wheel, and that's what we're looking at here, a colour wheel. And on that wheel you can see the different colours, like red moving round to orange, yellow, greens, all the way around to blues and purples and back round to red again. That's the basis of this colour model, and it's quite familiar. We all like colour wheels, they're quite nice, quite friendly. The way we describe a colour is by saying where it is on the circle, and the way to do that is to use an angle. Let's have a look at another picture. So this is another colour wheel, same one actually, but with fewer colours showing. But what it does show are numbers for the angle for those colours. So red is at 0 degrees here, and then if we move around the circle up to 90 degrees, that's a quarter of a turn. We've got green. If we move around again to the opposite side of the circle, we've turned all the way around, which is 180 degrees, and that's where we get this cyan colour. And then if we move all the way around again, 270 degrees, and we've got this kind of purpley colour, and then we go back around to red again. So we can use these angles to decide which colour we're picking. So yellow, let's go back to that other picture. Yellow's at 60 degrees. Great. Let's do a bit of coding and then come back to this. So I've logged in to Open Processing as usual. I've enabled the Simple.js library, and in the setup section I've enabled simple. This is what we always do in almost every video we've done, I think every single one. Right, so in our draw section we haven't written any code yet, and the easiest thing we can do is write a circle to draw a circle. If we say we're drawing it at 400, 300, then it's in the middle of the canvas, give it a size 100. And if we run that, we get a yellow circle. We've done this so many times now, I guess it's a little boring, but it's a good place to start because it's familiar. Right, now we want to tell our computer that we want to use not the default RGB way of mixing colours. we want to tell it that we want to use the HSB color model. So in setup, after simple, we choose our color mode, like this, color mode, and we say HSB in brackets. And now, when we say fill, instead of the red, green and blue numbers, we have to provide the hue, saturation and brightness. Now hue was this angle, so a hue of 0 is red, a hue of 60 degrees is yellow, a hue of say 100 degrees, 90 degrees, 100 degrees is that green colour there. So that's the first number. So let's choose 0 for red. Saturation and brightness, the next two numbers, what do they mean? Let's have a look. So this is the basic colour wheel showing the hue going around the colour. Now, in this version of that same picture, I've turned down the bright saturation to 50%. So back to the original, we are going around all the different hues and the saturation and brightness is turned up 100%. In this one, saturation is turned to 50%, and you can see the colours are weaker. It's almost like they've been diluted by water. So that red, you can see the red, let's compare it again. They're quite intense and a lot less intense. All the colours are a lot less intense. So the saturation has been turned down. What if we change the brightness? So in this version, we've saturation back up to 100, but this time the brightness has been turned down to say 70% here, and you can see the colours are darker. So saturation controls how intense the colour is, how diluted or not it is, I guess, and the brightness is similar to turning the light up and down. If I turn the brightness down even more, I guess these colours would get closer and closer to black. In fact, that is correct. So the brightness turned down to 0 means the colours go towards black. The saturation turned down to 0 means the colours go down towards white. Let's experiment with that. Let's first choose a hue of 0, which is red, and saturation and brightness of 100. So that should give us just a bright red circle. Yep, it does. Now let's change the saturation down to say 50. There, it's like it's been diluted with water. In fact, if I made that even smaller, it would be even weaker, a very light pink. Let's turn that back up, and let's just check that the brightness also works in the same way. There you go, a darker red going towards brown, I guess, but eventually, if I turn that down to say 10, it might be very close to black. Yeah, that is pretty much black. Okay, so that's just the first sort of experiment today with changing the saturation and brightness. And the first number we said was hue, and we said that yellow was at 60 degrees. Let's check that works. Yep. And we said maybe 90 degrees was some kind of green. Yep, that works. Okay, so that's the basics of HSB. The three numbers that we use are not red, green, blue, but hue, saturation and brightness. And you can see how if we had a colour like, I don't know, yellow, let's say yellow, which is 60 degrees, and we could work out how to calculate a darker version of that just by changing the brightness. There you go. Now we couldn't do that so easily with RGB. Okay, let's do an experiment. Let's draw a series of circles where the hue is changing between each of those circles. So we'll use a loop. Let's first create our own function. If you remember what functions are, they're just a way of packaging up code that we can use again and again. Have a look at a previous video if you need a reminder. We have covered it before. So I'm going to call my function myBlob. Could call it balloon, could call it anything else really. And I'm going to paste my code back in there. Now I'm going to use a repeat instruction to call that function many times, but I want to have a loop counter. Again, have a look at the previous video where we introduced repeat and loops and using loops with counters. If you don't know what they are today in this video, I really recommend going back to have a look. So we're going to have a counter that starts at 100 and goes up to 700 in steps of 20, and we'll call myBlob for each of those counts. That means myBlob needs to accept a parameter, which is that counter. Let's call it x. So when repeat is 100, myBlob is called with x as 100, and the next value is going to be 120, so myBlob will be called with 120, then 140, 160, and so on, all the way up to 700. And we'll draw the circle at x across, 300 down. Let's make the circle smaller. Let's say it's size 20. What else? Let's just see if that works for now. Yep, let's see if that works for now. Yep, that's a row of circles. That's what we expected. So each of those circles is drawn because x here is going from 100 to 700 in steps of 20. That's great. We've done all this before, so there's nothing new here. Now let's have the hue depend on x. So we could calculate a new hue. So we can say var hue, and we can say it is x if you like. Let's see if that works. That's nice and simple. That could work, that should work, but remember the hue goes from 0 all the way up to 360, and our x here goes up to 700. So maybe if we divide it by 2, maybe that'll fit it better. So the maximum there will be half of 700, which is 350. Let's see if that has an effect. What do we expect? Before we run the code, what do we expect to happen? Well, we expect circles to be drawn in a row. We've seen that already. We expect them to have different colours because the hue now depends on x, and that x will go from that hue, oops, mistyped that, that hue will go from 0 up to 350 because x goes from 100 to 700, so actually I'm wrong. That hue will go from 50 to 350. Let's run that. Ta-da! That's really cool. That's quite nice, isn't it? And you'll notice that's colours on that colour wheel, and we're going from one part of the wheel all the way around it, and we're seeing colours such as orange and yellow and greens and blues. Now we're not seeing the proper bright red, and the reason for that is hue is it's never 0, because when the counter is 100, x is 100, which means hue is 50. It starts at 50. There must be an easier way to convert that to the range we want, and there is. So let me draw a picture. Oops, so let me draw a picture. So let me draw a picture. So we've got X here, and we've got hue, and we have our X going from 100 up to 700, and we had our hue as half of X. So it went from 50 to 350, but we don't want that. We want it to go from 0 to 360. So when X is 100, we want it to be 0, and when X is 700, we want it to be 360. And when X is halfway, which is what? 400, we want it to go to 180. Now we could work all this out using some calculation with adding and subtracting and dividing, but it's a bit tedious, and luckily there's an instruction that helps us map one range to another range in a smooth way, so that if I had, say, 300, or what's halfway between those two, I can't make it out, but if that was the halfway point there, it would end up at 90 degrees there, and so on. And that instruction is called map. Let's use it. So the way you use it is you say map, and we're mapping X, which goes from the range 100 to 700, and we want it to go to 0 to 360. That's it. That's really convenient. So when X is 100, which it will be, hue will be 0. And when X goes all the way up to 700, the hue will go up to 360. So can you see how that works? Yep. So this is the starting range for X, and we want to end up in this range, and we use the instruction map to do that. Cool, it's a really handy function actually, it just avoids a lot of unnecessary calculating. So if we run this again now, we should get our colours actually starting at red rather than that orange that we saw. Let's see. Yep. We're now starting at red, going through all the colours and ending up back at red again. So that's really handy, that worked really nicely. We could stop there, but we haven't really played with the hue and saturation in this part of the experiment. So let's do that. Let's draw more circles above and below those ones. So let's use a nested loop. So for every one of those counts that goes from 100 to 700, we'll have another one that goes from 0 to 200, maybe in the vertical direction, which also goes up in steps of 20. So now we're passing a second parameter to the function, and we're drawing it at, let's say, 300 minus y. So what does this mean? It means we'll still draw a row of circles, but for every one of those we're going to draw some circles above that point, going from 0 to 200 in the vertical direction. Let's see the effect of that. There you go. And in fact we could draw another one that goes down, and we do that by adding, so we go below that line as well. Well, that's quite striking as it is. But the reason I'm doing these vertical circles is so I can vary the saturation. So let's calculate the saturation. Saturation, and we'll make it depend on y. And again, we can use Y and do some calculation, or we can just use map, which is really convenient. So we're mapping from 0 to 200 because that's what Y will be. It will start at 0 and go up to 200. Do you see there? In steps of 20. That's Y. And we want to map it to saturation. We could go from 0 to 100. Remember, saturation only ever goes to 100. Let's see the effect. So we're changing saturation. Okay, so at the middle we have 0 saturation, and as we move up and also down, we have the saturation increasing. What if we reverse that? This is the nice thing about map. We don't have to do any fancy algebra and calculations. We can just say, instead of starting at 0, start at 100 and go to 0. So we swap them around and that will reverse the direction. There you go. So that's quite striking. That's quite nice, isn't it? So in the middle we've got a strong saturation, and as Y increases, the saturation gets weaker. Great, that's nice, but let's not stop there. Let's change the size of the circle also. Let's say var size equals, and let's use this map again, Y 0. So we're making it depend on Y, which goes from 0 to 200, and we want it to start at 15 and go down to 1. So the circles start big in the middle and shrink as they move away. So let's see, circle size, that's it, that's the one we calculated. Let's see the effect. Nice. That's quite cool. I like that. Yeah. The outlines of the circles are a little bit strong as black outlines. Let's see if we can do something else with the let's say the stroke, so it's not the fill, it's the stroke, has the same hue, the same saturation, but it's just a little bit darker, so it has a brightness of 60. So we're taking advantage of the HSB colour model here. We're saying we're having exactly the same hue, the same saturation, but it's just going to be a darker version of that colour. Let's have a look. There. That's nice, isn't it? If you look closely, that green is a bright green in the middle, but a darker green outline. Same with the red. A bright red and then a darker red outline. A bright blue and a darker blue. And that works for all of them. So that's nice, isn't it? That's a slightly smoother effect. Okay. What else can we do? What we could do is we could shift those circles up and down a bit. Now, in a previous video we used mathematical functions like sine waves, so if you're not familiar with them, go and have a look at those. We introduce them really gently. So I'm gonna have another variable, let's call it shift, and I'm going to say it depends on x, so it will hopefully vary up and down as x increases, and obviously sine only goes from -1 to +1, so I'm multiplying it by 50, so the sine of x goes from -50 to +50. That's the shift, and I'm going to add that shift to the vertical position of those circles. There. let's see what effect that has. I think I can predict, instead of a rectangular grid of circles, I should have a wavy grid. Let's see if that works. Nice. Yep, that worked. That's rather nice, actually. I could stop there, actually. I think that's perfectly legitimate. That's really rather nice. Yeah, I like that design. I really do. I should stop staring at it and carry on. What else could we do? Oh yes, one thing that we haven't touched on is using translucency. Works in a similar way to the RGB model. We just add a fourth color, fourth number, sorry. So when we had red, green, blue, those are 3 numbers, and then we added a fourth number for how translucent the color was. We could do that here. We could say, let's call it the alpha value, which is actually what it's often called. And we can calculate that. We can say var alpha. We can map it from y, so it goes from 0 to 2, which y goes from 0 to 200, and we want to map that to what alpha should go from and to. Now, in the middle of the screen, we want it to be fully visible, so not translucent. In RGB, the numbers go from 0 to 255. So far here, we've had hue going from 0 to 360, saturation and brightness going from 0 to 100, and we've got the translucency, which has a different range altogether, which goes from 0 up to 1. So we want to start at 1 and go to 0.5. Let me draw a picture to summarise what we've just said, because that was quite a lot. So in RGB, these go from 0 to 255. And if we have a fourth number, which is the alpha value, the translucency, that also goes from 0 to 255. And that's red, green and blue. In our new model, which is HSB, and we might have a fourth translucency alpha value, the hue goes from 0 to 360, saturation goes from 0 to 100, the brightness goes from 0 to 100, and the alpha goes from 0 to 1. It is actually possible to change all of these ranges if you really want to. So you could make alpha go from 0 to some other number, but these are the conventions. They're easy to get used to, they're not particularly complicated. So that's why our alpha here is not going up to 100 or 255. Let's see what effect that has. Remember, we've changed now the stroke and fill instructions to include that alpha. There, they're fading off away from the middle. Lovely. I think I will stop there. We've covered a lot. Don't want this to be a very long video again. Yeah, so what we've done is we've looked again at this new colour model. We've shown how to use it and how to play with some of the parameters, how to change the saturation and the brightness, and even introduced translucency. And we've created quite a nice design with just a little bit of code. So yeah, I hope that was easier to understand than the long video we did before. And if you have any questions, do get in touch with the comments. Yeah, have fun, explore yourselves. You should definitely take the code and change it and try your own ideas. Remember, you can't break anything when you're experimenting in open processing, and the only thing that you do is you learn, and we all learn by breaking things, and that's really true of coding. So yeah, have fun, and we'll see you next time. Bye.